evaluate if possible. For these examples, we're going to evaluate the following limits by eliminating any power of lower degree. So in this first example here, the highest degree is 3 n cubed. So that means we can eliminate any terms that have a lower degree, leaving us with the limit as n tends to infinity. In the numerator, we have negative 8n cubed. In the denominator, we have 12n cubed. The n cubed terms cancel, and we're left with the limit as n tends to infinity of negative 8 over 12. The limit of a constant is just a constant, so the limit here is going to be negative 8 over 12. We can divide by 4. We're going to get negative 2 over 3 as the limit. In B, same approach. We're going to eliminate any terms of lower degree, so this one and this one and this one. We're going to keep this n because that n is actually multiplied by the n to the power of 4. So we're going to keep that, and we're going to get the limit as n tends to infinity. In the numerator, we're left with n to the power of 4. In the denominator, we have n times negative n to the power of 4. We can multiply out the denominator here. We're going to get the limit as n tends to infinity of n to the power of 4 over negative n to the power of 5. So at this point, the n to the power of 4 cancels against 4 of the n's in the denominator, which leaves us with the limit as n tends to infinity of 1, negative 1, over n. Now, we can substitute in the infinity, so we're going to get negative 1 over infinity, and this goes to 0, so the limit is 0. In C, we start by eliminating any powers of lower degree, so we can eliminate the following. I'm going to leave the 5 here because it's cubed, right? And this n over here is going to be multiplied. So in the numerator now, we're left with n to the power of 4. In the denominator, we have n squared times n. If we evaluate or simplify this a little bit, numerator is n to the power of 4, denominator is n cubed. The 3 n's in the denominator cancels against 3 of the n's in the numerator, leaving us with the limit as n tends to infinity of n. Now, this will be an unbounded limit, which means there is no limit, it's unbounded. As n tends to infinity, the limit goes to infinity.